Yo, what's good, y'all? So, bro, peep this out. I just figured out how to make a YouTube video for y'all and to make it so good. So, basically, we're going to do our study guide today. Let's hop right into it. So, you see here we have our study guide with our reference sheet, and we're told our scale factor is a ratio between our copy and our original. So, basically, if we wanted to find our scale factor here, we would do our scale factor is a ratio, right? And we can write from our actual to our scaled as well. So it's a ratio of 5 over 1, which just means it's equal to 5. And so that means if I do 1 times 5, aka my scale factor, I get to my actual. So I can scale. So how I go from my scale to my actual is by multiplying by our scale factor, which we have here to go from your scale to your actual. You multiply by your scale factor. And then that means to go from your actual to your scaled, you're going to divide by your scale factor. So you would do 10 divided by 5. So that means our scaled is 2. Which means if our scaled is 2 here, it's just, again, your actual is going to be 10. And it's just going to show you that that would be 10. And again, if we want to go from our actual to our scaled, we want to divide by our scale factor, which would be dividing by 5. And for this one, you can either do it by hand or by a calculator. For instance, 3. Ooh, I was using my thing. So 3 and 5/10 divided by 5 gives us 0 and 7 hundredths. So you know that's 0 and 7 hundredths. Or you could have done it out like this, right? 3 and 5/10. 5 goes into 3 0 times. Bring up our decimal. 5 goes into 35 7 times. And so you end up getting an answer of 0 and 7 hundredths. So that was kind of the reference sheet section. Let's go to question 1. All right. All right. So for question 1, this says each of these polygons is a scaled copy of each other. You already checked the corresponding angles, right? We remember that corresponding angles are always going to be congruent, meaning they're going to be equal. So that means angle B, F, and J are all equal to the same measurement because these are all scaled copies. And so you're told that the side lengths of each of the polygons are hard to tell from the grid, but there are other corresponding distances that are easier to compare. So also, sorry for the headset. Only way I can have a microphone while on my PC. So let's see if we can expand this out a little bit, like so. Bam. Good. All right. So here we're told that the side lengths of the polygons are hard to tell from the grid, but there are other corresponding distances. We're going to have to identify the distances in the other two polygons that correspond to segment DB and AC and record them on the table. So here we're told on our original quadrilateral that DB, segment DB, is 4 units. And then the vertical line AC is going to be 6 units. And so now what we want to do is we want to find the corresponding segment. So corresponding to DB on quadrilateral EFGH would be our next horizontal line here. So this would be segment FH. And the measurement for FH is going to be 1, 2, 3, 4, 5, 6. And so we can say FH is 6 units long. And then again, if we want to go to our vertical side again is going from G to E. And we can say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 units. And so we know that GE corresponds with CA, because if I was to place CA on top of this figure, right, these would match up as close as possible. So we would say GE is equal to 9 units, like so. And then finally on our last quadrilateral, IJKL, which is here, we know what corresponds to segment DB is going to be our horizontal line here, JL, and that's 1, 2. And then, so JL is going to have a side length of 2. And then KI is 1, 2, 3. So KI will have a segment of 3. And so we can see here that if we were to try to figure out like what's similar with all of these, is that we can tell that going from our original, right? If this is our original, copy 1, copy 2, right? We can see going from our original that our scale factor here, right, of 6/4. So our horizontal line, right, I'm multiplying by a ratio between my copy and my original. So 6/4. And that can reduce down to be 3/2, right? And then again, 9/6, right? Because it's a ratio, I can multiply by 9/6. And so that is divisible by 3 as well. So this would be 3/2. And so what we can see is we multiplied both the vertical and horizontal line by a scale factor of 3/2. Which, if we were to go here, right, we can see we multiply that by 3/2. But what about when we go from the original to copy 2? Well, here, these are corresponding. So I know I'm multiplying this by 3/6, right? So I'm multiplying this vertical line by 3/6, which is 1/2, right? And I'm multiplying our horizontal line by 2/4, which is just 1/2. And what we can see is that we multiply both the vertical and horizontal line by the same scale factor. So they're indeed going to be scaled copies. And that's something else that you want to notice is that all corresponding angles are congruent. So what do I notice of the tables? And also something else that we can note here is that all corresponding angles are congruent. What that means is that all the measurements of these angles that are corresponding are equal. And when you scale an image, the corresponding angles do not change. Sweet. Let's go on to question 2. So here on question 2, we have pentagon FGHIJ is a scale image of pentagon ABCDE. So here we have our original, and here we have our copy. And so if we want to count the side lengths, right, AB is here, 1, 2, 3, 4, 5, 6, has a length of 6. BC, 1, 2, 3, 4, 5, has a side length of 5. CD or DC, 1, 2, 3, 4, side length of 4. And then AE is 1, 2, 3, side length of 3. And then we go on to our second image. Here we have 1, 2, 3. Oh, sorry. Yep. 3 for FG. Now for GH, we have 1, 2. You see how this one's in the middle of the 3. So it's 1, 2, and then half. So it's 2.5. So GH is 2.5, or 2 5/10. And then HI is 1, 2. And then finally FJ is 1. And then this one is in between, right? So 1.5. And so we're told this is a scale copy. So what is a scale factor? Well, our scale factor is a ratio between our copy and our original. And so that means if I do my scaled length on our copy over our original, I get a ratio of 3/6. And so 3/6 can be simplified down by dividing by 3. And I end up getting 1/2. This means our scale factor was just 1/2, meaning that the size of our copy is half the size of the original. And so what is true about all corresponding angles in your scaled copy? Well, all corresponding angles in a scaled copy are congruent. So angles do not change when we have a scaled copy. So we would say all corresponding angles are congruent. And what the word congruent means is that congruent means that the measurements are equal. So since these are scaled copies, the measurements of all the corresponding angles will be equal, right? 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees. And whatever the measurement of this angle will be equal to this angle. And then same here, these would also be equal. All corresponding angles are congruent. I should make this one look less like a disformed box and more like what I have before. All right, let's go to question 3. All right. So question 3 says, scale the image below by a scale factor of 1/3. So if I count this, right, that's 1, 2, 3. Here I get 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Oh, I can't count. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. Again, I'm just like labeling the side lengths. 1, 2, 3, 4, 5, 6. And so when I scale something by 1/3, it means I'm multiplying all the side lengths by 1/3. And so multiplying by 1/3, we already discovered earlier in class, is the same as dividing by 3. And so if I want to make a table here to like organize, right, my original and my copy. So if I have a length of 3, 3 times 1/3, or 3 divided by 3 is 1. Here I have 9. 9 times 1/3, right? If I was to do 9 times 1/3, that would be 9 over 1, which is 9 over 3, right? 9 times 1 is 9. 1 times 3 is 3. And this is why multiplying by 1/3 is the same as dividing by 3, because this is 9 divided by 3, which is just 3. Here, 6 times 1/3 is the same as 6 divided by 3. So that means our copy will have a length of 2. And then again, we already did 3 times 1/3 is 1. 3 times 1/3 is 1. And then we already did 6. 6 times 1/3 would give us 2. And so now we can copy our length. So here we have a length of 1, right? That's what I had here, so I can check that off. Now we go from 9 to 3. So I go down 1, 2, 3. And now we go from 6 to 2. And then 3 to 1. And then 3 to 1. And then from 6 to 2. And what we can see is that here's a big L, and here we took a smaller L, and that was our scaled copy. So we had 1, 1, 2. And that's what it's going to be like on your test. And then finally, for question 4, here is a scale map of Lafayette Square, a rectangular garden north of the White House. And so what we can see here is the actual garden is 458 yards wide, right? And so we know our width here would be located here, right? And so what is the area of the actual garden? So let's find our scale factor first. Well, if the actual garden is 458 yards wide, right? That means I have 458 divided by 8. So if I do 458 divided by 8, I end up getting 57 and 25 hundredths, right, as my scale factor. And so if I want to go from my length, right, so my actual length right? My actual length is going to be 12 times my scale factor equals, so I can do 57 and 25 hundredths, right? It's already there. We can see up here it says 50 and 57 and 25 hundredths times 12 is 687. And so this means my area can be my length times my width, which just means, right, my width of 458 times my length of 687. And so I have 687 here, right? 687 times 458. And this would have given me an area of 314,646 yards squared. Or, right, so that's method one, where you get the actual measurements and then compute the area. Or you could remember is that since we already found our scale factor, right, you can get the scaled area. So 8 times 12 would be 96 inches squared. And then you could do 96 inches squared times your scale factor times itself. So we remember that the area is not scaled by the scale factor, but it's scaled by the scale factor times itself. So method one is finding the actual measurements and then computing the area, or you can multiply the scaled area by itself. You can multiply the scaled area by the scale factor times itself. So if we were to do this, right, we would do 96 times our scale factor, and we would get our area is equal to 5,496, and then we'd have to multiply it by our scale factor again. On your test, this question is going to be multiple choice, and they're going to give you one of the answers where you just multiplied the scaled area by the scale factor once. That's there to throw you off. You need to make sure that if you're doing method two, you're multiplying it by the scale factor times itself twice. And so then I can multiply 5,496 by my scale factor again. And how cool. We ended up getting the same area. I actually get nervous every single time that that's not going to work, but the math ends up mathing. And so that was question 4. And now we can move on to question 5. All right. So question 5. A blueprint of a park uses a scale of 5 inches to 8 feet. If the scale length of the park is drawn to be 20 inches, what is the actual length of the park? So here we have our scale, right? Our scale is 5 inches to 8 feet. And we know that if the scale length of the park is drawn to be 20 inches here, right? What does this feet need to be? Well, this is just equivalent ratios. What do you multiply 5 by to get to 20? You could see that that would be 4. 5 times 4 is equal to 20. Whatever we do to the left, we do to the right. 8 times 4 would have given us 32 feet. And so that means the actual length of the park, the actual length is 32 feet. Bam. So if the actual width of the swing set at the park is 20 feet, how wide is the scaled width at the park? So here you're paying attention to units, right? It's no longer inches. So we write down the same ratio that we had up here, right? Where we say 5 inches to 8 feet. But we need to make sure that the 20 feet goes here to 20 feet. And so we need to figure out, what do we multiply 8 by to get to 20? This is where you need to know, right? If I was to write this, 8 times some number equals 20, that is equivalent to 20 divided by 8 is equal to, bam. So here you have a calculator. If you didn't have a calculator, you would have had to just do 20 over 8, and then you would have simplified it down, right? And you would have gotten 10 over 4, and then simplify it again. 10 over 4 divided by 2 is 5 over 2, right? So you know you would have to multiply it by 5 over 2, or because you use a calculator, you can, oh, I keep using my like screen. You can do 20, right? We can do 20 divided by 8, which is 2.5, right? And so what this means is we multiplied 8 by 2.5, and whenever we do the right, we do the left. And 5 times 2.5 ends up giving us 12 and 5/10 inches. So we would say the scaled width is 12 and 5/10 inches. Bam. All right. So here we can now go to question 6. A model airplane is built at a scale of 1 to 72. If the model plane is 8 inches long, how many feet long is the actual airplane? So this one's a little different. Here, remember, 1 to 72, that's our scale. But do you see how there's no units? This means that our actual is 72 times greater. And 72 times greater just means you're going to multiply by 72. So here I have 8 inches is our model airplane. So the actual airplane is going to be 72 times greater. So I do 8 inches times 72. And maybe I do this on the side here. 8 times 2 is 16. Regroup my 1. 8 times 7 is 56. 56 plus 1 is 57. So this means I end up getting 576 inches. But you're not going to be like, hey guys, look at that plane. It's 576 inches long. No, you're going to convert that to feet. We know that there's 12 inches to a foot. And to go from inches to feet, you divide by 12. And so 576 divided by 12. 12 goes into 5 0 times. 12 goes into 57. Well, I know 12 times 5 is 60, so it must go in 4 times. 4 times 12 is 48. Regroup. 17 minus 8 is 9. Drop down my 6. 12 goes into 96 8 times. And I end up getting 48 feet. And so we would say the actual airplane is 48 feet long. And that was question 6. And now we have our last question here, where we have a scale drawing. Right here it says it's a scale drawing of a playground of 5 centimeters, 10 centimeters, 7, 5. And it's saying that our scale is 1 centimeter to 30 meters. So here, right, I can drop down my scaled images. So 5, 5, 10, and 7. And we know that our scale is 1 centimeter to 30 meters. And I know when I apply my scale factor going from my scale to my actual, I multiply by 30. 5 times 30 is 150. Again, I multiply each of them by my scale factor, which is 30 meters. And so 5 times 30 is 150. 10 times 30 is 300. 7 times 30 is 210. And so that was the table representing our original scaled copy going to our actual. On part A, it says make another scale drawing of the same playground using a different scale where it's 1 centimeter to 20 meters. And so the most common mistake people do is they take the measurements from this scale drawing and put it here. We're going to get a different scale drawing, but one thing that doesn't change is like the actual size of the park, right? When we saw that actual size of the park and then we did a scale drawing here, the actual size never changed, right? And so that means that these actual numbers here are just going to be the same actual numbers here, right? The park is still going to have this side length be 150 meters, right? They're all going to have the same length. Ooh, 300 and then 210. That's why you should do it in pencil. If I did it with pencil, you guys wouldn't be able to see it on the camera. And so here, this has a scale factor of 1 centimeter to 20 meters. And I know when I go from my actual to my scaled, instead of multiplying, going from scaled to actual, you do the reverse. So on your table, when you go right to left, you divide by your scale factor. And so here I would divide by 20. And 150 divided by my scale factor here of 20 would give me 7 5/10. And so I would do that for each one. 150 divided by 20 is 7 5/10. 300 divided by 20, maybe I do that on my calculator, is 15. And then 210 divided by 20 is 10 and a half. So if I was to draw my new scaled copy, right, it's 7.5 centimeters by 7.5 centimeters. Oh, I lied. This one is here, so that would be the 15 centimeters. Right here, 7.5 centimeters. Then we go all the way down here. And we know that this one corresponds with the 15, no, with the 10 5/10. And so, again, the most important part is to understand that the actual measurements don't change when you go to your second one. And so on your test, it's going to be like, here's map 1, here's map 2. Map 1, you're going to have to find the actual distance. And then you're going to have to use that same actual distance with your new scale factor to get the scaled measurement. It's actually much easier than this. So how did the scale drawings compare? Well, when our scale factor decreased, our scaled measurements increased. And so what we learned here is that when your scale factor goes down, right, when our scale factor went down from 30 to 20, our scaled image got bigger. And it works the other way. If our scale factor went up to 40, then the scaled image would go down. And so that's what we would have noticed here. And that's our test. Good luck, y'all. And hopefully you guys like the video. I actually kind of got like a kick out of this.